Okay, so some people asked for added support from chapter 4 on classifying triangles. So I'm going to walk through my notes again and do a couple examples. Hopefully these will help. If you look through these and want to take that past test from 2 weeks ago or retake it, please let me know. I'll get you a new test. So classifying triangles. Here's the basic. You classify by angles or sides. When you classify by angles, your answer is either right, equiangular, acute, or obtuse. 4 choices. Here's your process. First, go to your triangle, find the largest angle in the triangle, the largest one. When you find that largest one, if it's more than 90 degrees, then your answer is obtuse. So if I go to a triangle and find a 100-degree angle, then my answer is obtuse when I classify by angles. If the angle equals 90, then your answer is right. A 90-degree angle is a right angle. If a triangle has one right angle, it's called a right triangle. For C, if you find the angle equals 60, this one's been a little tricky for people. If you find that the largest angle in your triangle is 60, that means all of them are 60. And if you have 3 angles, all the same, we call it equiangular. Equi meaning equal, angular meaning angles. 3 equal angles, equiangular. If we look at that largest angle and it's less than 90 and not 60, then my answer is acute. The key here is not 60, because remember up here, 60 means it's equiangular. So if my largest angle in my triangle of the 3 angles was 80 degrees, I'd say that's less than 90, it's an acute triangle. Second part is doing it by sides. When we do it by sides, we have 3 choices: equilateral, isosceles, scalene. 3, 2, 1. If all 3 sides of the triangle are the same length, we call it equilateral. Lateral means sideways or sides. So it means equal sides. 3 equal sides means equilateral. If only 2 sides are the same, it's isosceles. Isosceles means 2 sides congruent or the same length. If all 3 are different, then we call it scalene. So the lengths of the sides are 3, 4, and 5. That would be a scalene triangle. If they were 3, 3, and 4, it would be isosceles. If they were 3, 3, and 3, it's equilateral. So if I look at these examples here, I go and you see the red circles. I've gone to the largest angle in each of these triangles. So to classify first by angles, I'm going to look. It's 90. My key above says it's a right triangle. All 60. This one is not acute. They're all the same. So we call it equiangular. One larger than 90, 121. It would be obtuse. Again, equiangular here. This little box means it's 90 degrees or a right triangle. And again, a right triangle. When we do it by sides, we've got 2 parts to this answer. Got to do both parts. I've circled congruent sides in blue. So this one has 2 congruent sides from before. That is isosceles. This one has all 3, equilateral. This one has all 3 equilateral. Notice here, these 2 terms always go together. If it is 3 congruent angles, 3 congruent sides, that always happens in pairs. It always goes together. So I never have an equiangular and isosceles or equiangular and scalene. So always equiangular and equilateral. Going to this one, my sides are 3 different sizes, 3, 5.1, 7.1. That's scalene. Another one, 3 different sizes, scalene, to the same isosceles. One more example, to the same, more than 90. Obtuse, isosceles. Obtuse, isosceles. All right, if I look at these triangles, I look at it. All these angles are acute. They're all less than 90. These ones here, these two sides are the same. That would be isosceles, acute. 2 answers to those type of assignments. This section here, remember that angles add in a triangle add up to 180. How do I find this missing angle? I'm going to add these two together. That's going to equal 111 degrees. This plus this. Oops, sorry. If I add those, it's 111 degrees. I subtract that from 180, and I find out that this angle is 65. Here and here, 130 plus 20 is 150. Subtract that from 180, this angle is 30 degrees. This section here talks about congruent triangles. This statement right here, this statement right here, means this triangle is congruent to this triangle. We use these markings on the side to say which sides are congruent. So I see 1 slash here and 1 slash here. That means side JI is congruent to side RT. 2 slashes here. Side JK is congruent to side RS. We do the same thing in the angles. This little arch here, little curvy mark, means angle I. And if I want to finish this sentence here, angle I, which one is it congruent to? I got to go over to the other triangle and find where there's only one. Angle I is congruent to angle T because it has one. Angle J is congruent to angle R because it has 2, and so forth. So the answer to this, angle I, would be congruent to angle T. If I go over here, HG is right here. There's 2 slash marks on it. So I'm going to go over here. RQ is congruent to HG. This section here has what we call exterior angles. They're angles outside the triangle. What our statement here is that the 2 interior angles add up to the outside angle or the exterior angle. So I want to find out what this angle right here is. I got to figure out what I add to this to get to this. Another way to say that is I can take this and subtract this. So my answer for this angle here would be 30 degrees because 30 plus 98 is 128. Another example here, take this, subtract this. That angle is going to be 70. So this plus this has to equal this, exterior angles. These are what we call special right triangles. In this 45, 45, 90, these 2 angles are 45, these 2 angles are 45, means these 2 sides are the same length. So the easiest one to do over here is to say if this is 6, then this is 6. Now we could do this 6, 6 and do the Pythagorean theorem and find the hypotenuse. What our shortcut says is that we just take this number of the sides that are congruent, that make up the right angle, and we multiply it by radical 2 or square root of 2. So for this answer here, y would be 6, and x is 6 times the square root of 2. If this is 6√2 and this is 6, if we go over here and apply that, we say, well, this number right here is the length of these two sides. So in this one, x and y are both 3. That's how a 45, 45, 90 triangle works. Again, here, we take this number here. This is 2, this is 2. If I look at this one, now I've got a 60-degree angle, not the same process as this. It's a different type of triangle. That means if I figure this out, 90 plus 60 is 150. This is 30. These are called 30, 60, 90 triangles. What we find out is there's a short side, a longest side, and a middle side. Remember, the longest side is always the hypotenuse opposite the right angle. The relationship between the shortest side and the longest side is a 2-to-1 ratio. The longest side is always twice as long as the shortest side. So I know from this picture that y has to be 6. And then we could do the Pythagorean theorem again. If we did, we could find this. But our shortcut in this type of triangle is that if we know the shortest side, the middle side is that amount times the square root of 3. It's a square root of 2 in the 40, 45, 45, 45. It's a square root of 3 in the 30, 69. So this side here is 6. This side here is 6 square root of 3. That takes you through the basics of the test that we did on classifying triangles and special right triangles. Hopefully that helps. I'll post this recording. You can access it anytime you need it.